In the last video, we went over a very brief and graphical sort of introduction to limits where the answer would be infinity or negative infinity. And we learned how to solve them graphically, but a lot of the time you're not going to be given the graph for infinite limit questions. It's going to be up to your algebraic manipulation skills. Well, in this case, it would be solving skills to figure out what the limit is approaching. Is it approaching infinity, negative infinity? Does it not exist? So in this video, we're going to be looking at the same function we looked at in the last video, which is f of x equals x plus 3 times x minus 2 all over x plus 3, x plus 5. So for this kind of question, you're going to be given a limit. So in this question, since x plus 5 is the only 0 on the bottom, so x equals negative 5 is the only 0 on the bottom that isn't on the numerator, we're probably going to be given the limit as x approaches negative 5. And let's start from the left. So let's say we don't know what this graph looks like. We have no idea what this function looks like on a graph. How do we solve this? We can tell there's going to be a vertical asymptote at negative 5, but we don't know if it's going to be from the left going all the way up or all the way down. We don't know if it's going to be infinity or negative infinity. So let's first think about this logically. If we were to have a graph right here, and then at negative 5, we had a vertical asymptote. If we were to plug in a very close value to negative 5, somewhere in this region, if we were to just plug in a value so close to negative 5 from the left of the vertical asymptote, if we get a positive answer, then it's obviously going to be going infinitely upwards. Where if we get a negative answer, it'll be going negatively downwards. It'll go infinitely downwards. So what we really have to do is just kind of mimically plug in a really close value. And what I mean by that is we don't have to solve for this plugging in a very close value. We can just kind of think about it. So let's choose a value negative 5 that is very close to negative 5 but isn't. So let's choose negative 5.0000. It could be as many zeros as you want, and then just at the end 1. And we do not have to plug this back into this function. And I'll tell you why. We're going to set up a mock plugin. So we're going to have x plus 3, x minus 2 over x plus 3, x plus 5, where x is going to be equal to negative 5.0001. So, you know what? Actually, to begin with, you'll see what I mean in a second. Let's just start with negative 5.1. We're still going to get the same answer, but it'll be a lot easier with just negative 5.1. In actuality, you'd want to use a much larger number because there could be sources of error here. But right now, let's just start with negative 5.1. Negative 5.1 plus 3. I don't want the answer. I just want the sign of what it's going to be. So let's just try and get the signs of all these. So negative 5.1 plus 3. So we're going to try this one first. Negative 5.1 plus 3. Well, negative 5.1 plus 3 is going to be negative because negative 5.1 is, has a larger magnitude than 3. So that's going to be negative. Then negative 5.1 minus 2. That's just going to make it more negative. So again, we have a negative. Then over negative 5.1 plus 3, that's also going to be negative. And then negative 5.1 plus 5 is going to be negative again. Because negative 5.1 plus 5, here we can kind of solve in our heads. We can just get rid of the 5. So if we add 5 to negative 5.1, we're just going to get negative 0.1. So that's going to be negative. And then if we solve for this, we're going to get a positive over a positive, which is just going to be a positive. So the answer to this limit is that it's approaching positive infinity. And this, in my opinion, is so much easier to solve than using end behavior models for horizontal asymptotes. So let's try again from the right. The limit as x approaches negative 5 from the right of f of x. So let's do the same thing we did for when we did the sign check. So let's do another sign check. So we have negative, so let's choose a value really close to -5. And for this time, I'm going to use the closest we can get. X is equal to -4.999. So let's try and add these two together. So -4.999 plus 3. Well, that's going to be negative because -4.999 is just going to outweigh 3 when we add them together. So that's just going to be negative. Then if we minus 2, that's just making it more negative. So that's just negative again. The -4.999 plus 3, we already answered this up here. That's going to be negative again. And the -4.999 plus 5 is going to be positive. Because this right here, if we add -4.999 to 5, well, 5 is going to outweigh this number because it has that one extra sort of push to it that's going to outweigh the 4.999. This right here is not -5. It is not -5. It's very close to -5, but there is an end to it, that final 9, that makes it not -5. So since it's not -5 and we're adding 5 to it, it has to be greater than 0 because it doesn't cancel it out and it's not greater than 5 in terms of magnitude, in terms of absolute value. So -5, so -4.999 plus 5 is going to be a positive. So we get a positive over a positive times a negative is a negative, which is going to be a negative. So the limit as x approaches -5 from the right equals -infinity. And if we were to take the limit as x approaches -5 just regularly of f of x, that would be does not exist because it's approaching two different things from two different sides. So let's look at a new example, because if you watch a previous video, you've already known the answers to these. And let's go over one more example. All right, so let's look at this example. F of x equals x squared plus x minus 12 over x minus 2 squared. So the first thing we're going to do is we're going to find the vertical asymptotes, and then the question's asking us, what is the limit at this value? So let's take it one step at a time and find the vertical asymptotes. So we can rewrite this expression, or this function I should say, in factored form. So x squared plus x minus 12, well, you can rewrite that as x plus 4 times x minus 3, because foiling this, you'd get x squared plus x minus 12, and you could say, okay, so it has to multiply to -12 and then add it together. The two numbers have to equal 1, and so that's 4 and -3. All over, and I'm going to keep that in the form it is, x minus 2 squared. So let's see. Well, the one thing, the factor, or the 0 I should say, in the denominator that's not in the numerator is right here, this x minus 2 squared, and that's going to be at x equals 2. So find vertical asymptotes, that's going to be at x equals 2. And then what is the limit at this value? So what is the limit of f of x as x approaches 2? So let's try and figure that out. So the limit as x approaches 2 of f of x, well, we can't plug it in. There's no way to factor that. But we can say that this is equal to both this has to be, so it has to be equal to the limit as x approaches -2 from the left, which also has to be equal to the limit as x approaches 2 from the right of f of x. So let's do all of this together right now. So let me rewrite this function down here. So let's first start off with the limit as x approaches 2 from the left of f of x. So let's choose a number really close to 2. That's not 2, so we could say like 1.999. So make it really small. So let's try plugging that in. So we could say, well, 1.99 plus 4, that's going to be positive. It's just a positive plus a positive. Right here, 1.99 minus 3, well, 3 is greater than 1.99 in terms of absolute value size. So that's going to be a negative. And then 1.99 minus 2, that is negative, but we are squaring the number here, making this positive. So it could be a negative over a positive, which equals a negative, meaning that this limit is approaching negative infinity. And then let's check from the right. So the limit as x approaches 2 from the right of f of x. So let's choose a number really close to 2 from the right that isn't exactly 2. So we could say 2.0001, let's say. And let's test this out. So 2.0001 plus 4, that's just a positive plus a positive, so a positive. 2.0001 minus 3, well, 3 will outweigh 2.001, so that's going to be a negative. And then divide that whole thing by 2.001 minus 2. Well, that's going to be positive. Squared is a positive. And that's going to equal negative over a positive, which is just going to equal a negative. So the final answer to this limit is that limit from the right is that it equals negative infinity. And since the limit from the left equals the limit from the right, we can say that the limit as x approaches 2 completely of f of x equals negative infinity.